Hi there. Hope you have a fantastic day today. This lesson, I will go through 2021 HSC paper with you. Of course, there is the PDF versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 31. The table is the present values interest factor for an annuity of $1. Okay, keep that in mind. A bank lends Martina $500,000 to purchase a home with interest rate charge at 1.5% per annum compounded monthly. So we know that the interest rate is 1.5% per annum, but then we compound it monthly. So we just convert to monthly first. So R is 1.5%. We divide it by 12 because there are 12 months in a year. So just go 1.5 divided by 12. So that is 0.0. So that is 0.125. So 0.125%. But then the table is given is in decimal form. So we just divide by 100 because we need to convert percentage into decimal. So if I divide by 100, that will give me 0.00125 because otherwise you can just go 0.125 divided by 100. So you should get 0.00125. And N is 30 years, but then she paid monthly. Okay, so therefore 30 years, so 30 times 12. So we just go 30 times 12. So 3 times 12 is 36. Then we add a 0. So N is 360. Now we just need to work out how much should the monthly repayment be in order to pay off the loan in 30 years. So that is 360, okay, for N. So if we think about it, so N is 360, is here, and R is 0.025 is this. So therefore, if you go down, and then you go across, so this is the present value interest factor. So in another word, if she borrow this amount, so the annuity will be $1. Okay, so let me just write this down first. So annuity, that means monthly payment, $1. She will be able to borrow this amount. So this is $289.75411. Okay, but then she borrowed $500,000. So 500,000. So what we do, we just need to work out the scale factor from here to here, how many times. So therefore, we need to do the same thing on the left hand side. So just go 500,000 divided by 289.75411. So there you go, 1725.60. So we times 1725.60. So we do the same thing on the right hand side. So 1 times 1725.60. So will give me 1725.60. So that is her monthly repayment. So therefore, $1,725.60 per month. So there you go. Question 32. So we need to find the length of XY. So XY is this length here. Now, because it's a right angle triangle, so we can use SOHCAHTOA. Okay, so this angle is given. So this is the hypotenuse. So that is 16 centimeters. So height. And XY is next to 30 degrees. So that means adjacent. So we have A, height. SOHCAHTOA. Remember? SOHCAHTOA. And we have A and H. So we use this one here, Ka. And C is for cost. So that means cos of 30 degrees, which is C, and equal adjacent, that is xy, over the hypotenuse h, that is 16. So if I times 16 on both sides, times 16, so that cancel out. So that is xy is 16 cos 30 degrees. So therefore, xy is 16 times cos 30. So 13.856 and so on, and correct to 2 decimal place. So should be 13.86. So 13.86. And don't forget the unit. So centimeters. Part B. Hence, find the area of the shaded region in square centimeters. Correct to 1 decimal place. So we can see this. We have a semicircle and a right angle triangle. But then we know that to work out right angle triangle is a half times base times height, 2 perpendicular lines times together. So we need to find this length. But then we don't need to do that. We can also use a half AB side C. Okay, so area of any triangles is a half AB size the angle in between. So side C. So keep that in mind. Okay, so what we do to work out the area shaded, we just find the area of a semicircle, and then we minus the area of the triangle. So area of a circle is pi r squared. That gives me area of the whole circle, and we just times a half because we only have half of the circle. We can see here. Okay, and the radius is 8 because the diameter is 16. Keep that in mind. And then we minus area of a triangle. So the triangle there, here, a half AB side angle in between. Okay, so now we just substitute the value in. So pi times the radius. So the diameter is 16. So radius is half of this. So that means 8. So which is 8 squared. We times a half. And then we minus area of the triangle. So it's a half. So we know the side angle between is 30 degrees. And xy is 13.86. So we just go times by 13.86. And we times by the length of this, which is 16. And we times the side angle in between, that means size of 30. So there you go. Okay, so now what I do, I just put on a calculator. So I just go shift pi times 8 squared times 0.5 or times a half if you wish. We minus 0.5 times 13.86 times 16, and we times sine of 30, close the brackets. So there you go, 45.09096 and so on, but correct to 1 decimal place, so it should be 45.1. Okay, so 45.1 square centimeters. There you go. Question 33. So we know that the equations of the regression line is this. This is this line here. Okay, keep that in mind. And then the correlation coefficients is this. So let's see what the question is asking for. By using the equations of the regression line, predict the average maximum daily temperature in degrees Celsius for a town is 450 meters above sea level, and we need to give the answer correct to 1 decimal place. So first of all, we need to know that x is the height above sea level in meters, whereas y is the maximum temperature in degree Celsius. So to work this out, so we know that X is this. So we have the equations Y equal to 29.2 minus 0.011 times X. X is 540. So that is equal to 29.2 minus 0.011 times 540. 23.26 degrees Celsius. And correct to 1 decimal place. So 22.3 degrees Celsius. Part 2. The gradient of the regression lines is negative 0.011. Interpret the value of this gradient in the given context. So first of all, we know that gradient is rise over run. So it's like this, okay? Which is draw a triangle first, a right angle triangle. So like this. So the rise is the maximum daily temperature and the run is the height above sea level. But because it's negative, so that means it's going down. So that means the gradient is negative 0.011. So that means every meters that the height of sea level increase, the average maximum temperature is decreased by 0.011 degrees Celsius. Okay, let me just write this down. So there you go. Part B. So this graph is show the relationship between the latitudes, X degrees south, and the average maximum daily temperatures in degrees Celsius, okay? And the equations of the regression lines is this, and the correlations coefficients is this. Now the question is, which measurements high above sea level or latitude would be better to use to predict this town average maximum daily temperature? So we need to give a reason as well. So to work out which one is better to use to predict the maximum daily temperature, so what we do, we just need to look at the correlations coefficients. So we have the correlation coefficients for high above sea level is this. So let me just write this down here. So there you go. It would be better to use latitude to predict the average maximum temperature for the town because it has a strong negative correlations coefficient, whereas high above sea level has negative moderate correlation coefficients. Okay, thank you so much for watching. Bye.